Okay, hello everyone. So today we'll begin our P4 TASMO knowledge preparation. So in these days, I will just introduce some very basic computation knowledge point. And this is very useful not only in our the TASMO competition, but also in the NEMO's competition. They are just several very common test points. Okay, so the first one, yes, let's talk about a very important things in math about a calculation. So we will learn some calculation formula and you don't need to prove it every time. So I will show you how to prove that. And every time once you meet it in the competition, you can just directly use them. Okay, so the first one is a very important thing is about the difference between two square number. So difference between two squares. Hey, so it should be like the a square minus b square. A square minus b square. So how to prove that? So I will tell you the formula is a square minus b square equals to a minus b times a plus b. And this one, if you want to calculate from right to left, it will be very easy, right? Because once you open the bracket, a times a squared, a times b plus ab. Then minus this part, minus ba, then minus b squared. Of course, this one it should be a squared minus b squared. But actually, you are very not so familiar with the how to times the two ways, two unknown letters in two bracket. So I will use another way to prove that. It's about the geometry. Okay, so we can use geometry to prove that. So what is a squared minus b squared? So imagine I have a big square. I have a big square, in which the length is a. And now I have a smaller square, for example, inside this big square, and the side length is b. The side length is b. So now, if I want to calculate the shaded area, right? This shaded area actually is just the a square minus b square. But so remember, for if I want to calculate this shaded area, we usually use two methods. The first one is use big area to minus the small area. So in this question, yes, of course, I just use what? I just use the big squares area to minus the smaller squares area. Okay? So it should become like the a squared minus b squared. Of course, this is on the left part of our equation. And so now the second one. So usually we can use another way to separate them. So now let's do the separate. So if I connect this line and connect this part, right? So because this part actually the length is b and this one it will be a minus b. So if I want to calculate the shaded area, right? If I want to calculate the shaded area, I can just move this small rectangle to the right, right? I can move this small rectangle, I clean it, and I move to the right. So on the right part, it will be a new rectangle. So this rectangle is same as this smaller one, okay? So these two parts are same. So now let's find out what is the side length and what is the base and what is the length. So for the base, we know this is a minus b, this is b. In this part, because I move here, it will become b. And about the length, okay, so this part, this is the base, it will become what? It will become a minus b. It will become a minus b. And also it's the reason why I can just move this small rectangle to the right. So now what is the length? The length, it will become what? A minus b plus b plus b. Here is the total length. And how about the base? Base is just the a minus b. And remember, we are calculating the same part area. So we can have the conclusion, which is a squared minus b squared. This one we do the simplify, it will become a plus b times a minus b. So equals to a plus b times a minus b. Okay, so this is the difference between two squares. And also we have another very useful thing is the sum of two squares. So the formula is like the a plus b squared. Okay, a plus b squared. So this one is like the a plus b times a plus b. So you can also use my first method to do the separate. It will become like a times a plus a times b plus a times b times a plus b times b. So it will become a squared plus ab plus aba plus b squared. So simplify it, it will become a squared plus 2ab plus b squared. So this is also a very important thing. But how to prove that, like in geometry? So a plus b squared, that means I have a square, right? I have a square. But this time the length is what? The length is a plus b. So that means I can draw here. This is the small square, which length is a. And now this is the small square, which length is b. So this is b, this is b. This is a, this is a, this is b, this is b, this is a. So you can see this is about, if I want to calculate the total area of this square, it's just the a plus b square. The total square. And now how about the second one? So I can also use the separate method, right? So I can separate into each part. So this part, let me use this blue pen, it will become a squared, and the right part, b squared. And top right one, it will be a times b. Top left one, it will become a times b. So I plus them together, it will be a squared plus ab plus ab plus b squared. So in total, yes, we can have the formula is a plus b squared equals to a squared plus 2ab plus b squared. Okay, so these are two very important formula in math calculation. So also let me introduce a little harder one. But this harder one, so maybe we can use this method to prove that. But also I hope you can always remember the formula. It's very important. Okay, so now let's see this example. As shown below, we have the three identical triangular tables, and each table contains 1, 2, 2, 3, 3, and so on, right? Until 10. So firstly, can you tell me if I want to calculate the sum of numbers in each table is 1 square plus 2 square plus 3 square, right? Because this is the definition. 1, 1 is 1 square. 2, 2 is just 2 square, and 3, 3 it should be 3 square, like that. Okay? Okay, so now let's think about how many numbers do we have in each table. So you can just use the Gaussian sum, which is 1 plus 2 plus 3 plus blah 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 plus 10. This one, it should be 55. So that means we have 55 numbers in one triangle table. So now let's look at the second one. The sum of the three numbers that fall on the same position in three triangular tables is what? So let's look at that. So you can see it's 1, 10, and 10. So what is the sum? The sum is 21. Now maybe let's look at another one. 2, 10, and 9. What is the sum? It's also 21. So maybe I randomly choose 1, 10, 10, and 1. The sum is also 21. That means no matter how I choose the position in one triangle, the sum of these three triangles is always 21. It's always 21. And then, what is the sum of all numbers in the three triangular tables? What is the sum? Because in total, how many positions do we have? We have 55 positions. So we should use 55 times 21. Okay, it equals to 1155. But remember, I want to calculate do I need to calculate all the numbers in this three table? No, we don't need, right? We only need one. So the answer, it should be 1155 divided by 3 equals to 385. So this is if I want to calculate 1 square, 2 square, the sum of 1 square, 2 square to 10 square. But now, this time, let's do the change, okay? So I will use this green pen. This time, if I want to find out 1 square plus 2 square plus 3 square plus blah 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 plus 2 n square, what is the sum? So for example, if I have n square, so let's still answer the same question. The first question, there are how many numbers in each table? So remember, we are calculating 1 plus 2 plus 3 plus blah 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 plus 2 n. So using the Gaussian sum, it will be the first number plus the last number times how many numbers do we have? Then divide by 2. Right, so now let's look at the second answer. So the sum of the three numbers that fall on the same position in three triangular table, it should be what? The first one, yes, still 1. The second one, because we have n numbers, so it should be n. And the third one was that it's also n. So for the second question, the answer now becomes 2n plus 1. So the third one, the sum of all numbers in the three triangular tables is what? It should be n, the first question, right? The first answer, n times n plus 1 over 2 times 2n plus 1. And then the fourth question, do I need three triangular table? No, we don't need. So we just divide by 3. So it should be n times n plus 1 over 2 times 2n plus 1 divided by 3. So the answer it should be what? It should be n times n plus 1 times 2n plus 1 over 6. Now we have the conclusion. The formula of 1 squared plus 2 squared plus 3 squared plus 2n squared, the answer should be n times n plus 1 times 2n plus 1 over 6. Okay, so we can have a check. If this time n equals to 10, so it will become 10 times 11 times 21 over 6. So cancel 3, 2, cancel 3, 7. Then it equals to 770 divided by 2 equals to 385. Okay, so I hope all you guys should remember this formula. It's very important in all the competition and very useful. You don't need to calculate it one by one. You just take the formula and take the number of n. You can get the final answer. Okay, so here is about 3 very important formula you have to know in not only in the TASMO but also in the NEMOS. Then also I prepare for 3 questions for you to answer. Okay.